In this video, we're going to review how to use the Pythagorean Theorem to find a missing side length of a right triangle. By now you should be familiar that right triangles have three sides. The longest side is what we've been calling the hypotenuse, and we always use for c in our formula for the Pythagorean Theorem. That makes the two shorter sides, the ones that form the right angle, the legs, and they take a and b in our formula. We know that there's two ways, at least two different ways, to write the Pythagorean Theorem. A squared plus b squared equals c squared, or we could rewrite it to say c squared minus a squared is equal to b squared. And both of these formulas have their places. They can help us at different times, and they both could be used to find any missing side length. Now, the two examples we're going to look at to review today are this red triangle with side lengths of 9 and 3 and an unknown, and this purple triangle 3, 12 and an unknown. For each of these two right triangles, pause the video and think, which of these two formulas would you prefer to use? Welcome back. Hopefully, you realize that for this right triangle, the red one, we don't know what the hypotenuse is, c, the longest side, so we should probably use a squared plus b squared equals c squared because we already know the two legs a and b. For the purple triangle, we don't know what one of the legs is. We already know the longest side. This is the hypotenuse. It's facing the right angle. We know one hypotenuse, one leg, but we don't know the other leg, A or B. So we should probably use this formula when we know C and one of the legs, which we're going to call A. Go ahead, pause the video now, and take the time to figure out what are the missing side lengths for the red triangle and the purple triangle. For the red triangle, we're going to ask you to round to the nearest tenth. And for the purple triangle, we're going to ask you to round to the nearest hundredth. Pause the video, figure out the missing side lengths, and when you come back, we'll walk you through it. Okay, welcome back. Hopefully, for the red triangle, your work ended up looking something like this. You realize we know the two legs, 9 and 3, so we substitute 9 in for A and 3 in for B. The next step is going to be to evaluate that, so we want to know what 9 squared is equal to. That gives us 81. And 3 squared, 3 times 3, gives us 9. The next step, we would add those two expressions together. So when we add 81 and 9 together, our equation simplifies to 90. And hopefully you understand now the last step for the Pythagorean theorem. Every time, the inverse operation that cancels out the squared that's attached to our unknown is to take the square root from both sides. So we're going to go ahead and apply a square root to the 90. We're going to apply a square root to the c squared. And the reason we're doing that again is that will help turn our c squared into just c. It's the inverse operation that canceled out the exponent of 2. And when we do the square root of 90, which is not a perfect square, it's going to give us an irrational number, we get 9.486 to the nearest tenth. That should have been 9.5. For the purple triangle, this time we know the hypotenuse, and we need to find a leg. So I'm going to go ahead and substitute in for c squared. We're going to need to replace the c with 12 because that's the hypotenuse and it has a value of 12. And we're going to replace a with 3 squared. For the next step, we're going to simplify or evaluate those exponents. 12 times 12 gives us 144. 3 times 3 gives us 9. So we get 144 minus 9 is equal to b squared. Now we're going to combine like terms. 144 and negative 9 are on the same side. They combine to make 135, and that's equal to b squared. What's our last step? As always, we need to take the square root to finish the Pythagorean theorem because that's how we're canceling out the exponent of 2. The inverse operation of the exponent, or squaring, is to take the square root. Square root of b squared leaves us with b. And when we take the square root of 135, we get 11.61895. It's not going to stay at 618. It's actually going to round up to 619. And again, the reason we're doing that is we're looking at, we need to do the nearest hundredth. As usual, I made a mistake. So if we go to the nearest hundredth, 11.61, we need to bump up to 11.62 because this 8 is bigger. Speaking of making mistakes, I should now go back and see if my answers are reasonable. 9.5, is that a reasonable number to plug in for R? Sure is, a little bit bigger than the 9. 11.62, is that a reasonable number for this purple side? Yes, it should be just a little bit smaller than 12.